So in Module 7, very good module actually, because we're going to talk about how do we maintain our wireless network, what are some of the troubleshooting tools that are available to us, how do we update licensing on our devices, how do we back up our device configurations if we have to do a device replacement, what tools do we have available to us to manage the wireless space itself. All right, we have a general understanding about how to implement these components, and through the lab exercises you guys have learned or will learn how to continually add additional pieces to the network. But in this module, we're going to talk about wireless maintenance, different troubleshooting tools that you have available to you, and what are the steps that I take? What is the different troubleshooting methodology that I'm going to use as I'm trying to identify issues in the network? The CCNP wireless goes obviously way more in depth into this particular topic, but at least this will give you some information that's valuable for your basic troubleshooting and gives you that basic knowledge. All right. We manage the wireless network pretty much like we manage the wired network, at least from a ongoing maintenance kind of concept, right? We have backups that we perform. We have operations that we can perform to make sure that the licensing is applied. We can upgrade the software. We can do this through the cloud for our AirOS devices, our iOS XE devices, and so on. So when we go through this lesson, I want to describe to you the different licensing options for all three of the architectures, the cloud architecture, the AirOS architecture, and the XE architecture, and then describe the different image update methods that you have for these various architectures. And then we'll look at how we do the actual backup and restore process of our controllers and so on. It's a relatively simple process. I mean, it's not a very difficult thing to understand. So keep in mind as we talk about these different technologies, and as I've mentioned throughout the entire course, there are two ways to do lightweight deployments: centralized and converged. Right? Centralized is what you guys are implementing in your environment. This is what you guys are used to using, right? Where you've got AirOS software running on a 2504 controller or a 5508 controller or a virtual controller. That's really the modern version of this autonomous or lightweight environment. iOS XE architectures means that we're running controller functionality within our 3850 switches or our 3650 switches, and we have different controllers throughout the environment based on that. All right, and then of course cloud is the Meraki-based solution. So if you take away anything, that's one of the things that I want you guys to understand is that process. All right. So let's start first by looking at the licensing models, right? Each architecture has its own licensing model, has its own licensing requirements. Cloud licensing is a subscription-based model, right? Licenses have a license start date, and licenses start counting from the date that they were purchased. Not the date they're added to the organization, but from the date that they're purchased. So it's going to be a subscription type model. Now, within the cloud licensing arena, there are several different components that get licensed, right? We have different device types. Licenses apply only to devices of one type. That means that you have to purchase a license for an AP that does not contribute to the number of, say, MX series security appliances that you have in an organization. So it's not a generic license for the cloud-based solution. You actually purchase a license for a specific physical device. The MX is the XM is the Meraki indication, and an X would indicate that it's a security appliance. Also, within the device category, a license for, say, an MX60 security appliance doesn't cover any other device within the MX series. So you have to buy a license specifically for a particular platform. Now, the Cisco Meraki licensing is applied on an organization-wide basis. We saw that on the previous screen here. Organization, license information. You can see the system manager license limit and current device count, wireless AP license limit and current device count. We only have one device attached to this particular Meraki, but it is applied to the entire organization. What that essentially means is that a license is not purchased for a specific device, rather for each license is added to the organization. That increases the number of specific device types that can be added to that particular organization. Right? Now that seems kind of counterintuitive to what we just talked about, but what I'm saying is it's a pool of licenses. It's still the previous explanation of the device types and how licenses apply only to the device of one type still applies here, but the licenses are shared throughout the entire organization, regardless of wherever that device might exist. I guess that's what I'm trying to say here. All right? The number of devices in an organization can't exceed whatever organizational license limit you have. You do have an opportunity to add additional devices and use them and be in what we call a non-compliant mode, but you have 30 days to where you have to go purchase the licenses and activate the licenses to be back in compliance. If you're not back in compliance by that period, that device will be shut down until the proper licensing is applied to the organization. If you do enter that 30-day grace period because you've exceeded the device limits, you get back into compliance by either removing the device itself, obviously, or purchasing an additional license. There is another time that an organization might enter the 30-day grace period, and that's if a license expires. Because remember, these are subscription-based licenses. They're not permanent, perpetual licenses. They're subscription-based licenses. So you want to make sure you maintain that information. In addition, you have the ability to do something called co-termination. The Meraki licensing is co-terminating. That means that the end date for all the licensing is averaged together based on the device type and the license limits. That essentially allows, you're adding devices continually throughout the process and throughout the life cycle of managing this environment, this cloud-based environment. It would be a pain to say, oh, this license expires on this date and this license expires on that date. So in the organization, you can add devices and licenses over time without having to worry about all those different dates that come into play. So this co-termination process is automatically calculated based on all the licenses that are added to the system. It doesn't depend on the current device count. It just depends on the license limits. So removing devices from a network doesn't affect the co-termination date, only adding devices. So let's say that I had 2 separate enterprise AP licenses for my organization. One license is for 2 APs that is a 365-day license, and another license is for 1 AP that's a 5-year license. So whatever number of days that is. The co-termination value gets calculated based on the number of APs and the number of days that are included in licensing for those APs. So let's say, oh gosh, let me calculate it. 5 times 365, that's 1,825 days. So I take the 1,825 days, I multiply that times 1 because I only have 1 AP that has that license. And then I take my 365 days and I multiply that times 2 because I have 2 licenses that fall within that group. I add that number together, I divide by 3. That gives me my average, right? Which ends up being about 800 and something days, all right? So that becomes my co-termination window. That make sense? Thankfully, we don't have to worry about this in a centralized environment, but this is the cloud-based solution, which is a subscription model. When license keys get applied as a renewal, the organization's licensing state updates to match the device count. So let's say I have licensing for 5 APs, where and we had 2 AP license that was applied as a renewal. The organization would only be licensed for 2 APs. The other 3 APs would be over the license limit, so you'd be out of compliance and you would go into that window, that grace period. In the cloud-based solution, the recommended practice for applying renewals is to purchase a single license key that covers every device in the organization for a particular number of years. You might not be able to do that initially as you're deploying devices, you're adding additional components, but in that average compliance cycle, say the 850 something days that we had in the previous example, when I get to that point, now I can purchase licenses for all the devices that are added to the system across the board to cover every device. And makes it a little bit easier to manage that information. Licensing in AirOS, much simpler. It's not really a subscription model. It's just licenses that you have to purchase. Licenses are pre-installed when you order the controllers, as like a 2504, for example, supports up to 25 APs. So if you order a 5508, you can actually purchase the 5508 with a base license count. Like for example, I just did this for one of my customers. They wanted a licensing for 80 access points. Well, there's actually a part number, CT5508-100, that includes 100 access point license, base license for that controller. All right. So the interesting thing is that when you install these base licenses or you purchase the base license with the controller, it includes all the features that are supported by that controller. So you don't have to have, like on a router, a UC license or a data license or a security license. All the features are automatically licensed. You're just licensing the number of access points. That happens through the use of the product activation key. You know, you go to your vendor, you buy the license, then you go to Cisco, or Cisco sends you a product activation key. You go to cisco.com/go/license, and you enter that product activation key with the serial number of the controller, and you go through the process of registering the license. And then you go under management, software activation, which is what you see on the screen here, and then you can license or upload the information. Let me show you that real quick. So if we go to management, all right, and we go to software activation, licenses, we can see that these are permanent licenses. This particular AP or this particular controller had an evaluation license that I installed for an additional 75 APs, but that's now expired, of course. But you can see the base AP count, 25 licenses. That's a permanent license. You can drill down into the license itself and kind of see, the details for that particular license. So this license was applied. Well, it's been expired for 12 weeks and 6 days. All right, and I could remove this license. Actually, you know what? I'm trying to think of when I applied that. I wonder if, let me check something. Yeah, status of inactive indicates that it's been expired, or maybe let me check something. Yeah. You can get these licenses from Cisco if you call them and say, hey, look, we're looking to add some additional APs to our controller. We haven't gone through the process of purchasing the license. We need an evaluation license. And then you can even ask them how long you want that evaluation license to last. And then typically, if it's a reasonable amount of time, they'll provide that. Okay? And you can also see the license usage here. I only have one AP connected, so I have 24 remaining APs. But the nice thing about this is that it is a permanent license, right? It's not something that you're going to have to pay for on a subscription basis. So here's the commands: install a license, save their credentials, rehost a license if you're going to move a license and so on. So if I did save credentials, I can specify the file name, click save, and it will, I have to set up TFTP and everything, but they would actually copy that via TFTP to a destination. I don't have TFTP configured on this device presently. Okay. So let's say that I ordered a controller with 100 licenses to start with, 100 access point licenses to start with. I can increase the capacity up to, on that particular model, up to about 500 access points. And you can't add them incrementally. Well, you can add them incrementally, but just not in increments of 1. You could buy 10, you can buy 25, you can buy 50, you can buy 100, you can buy 250, and so on. And the price is commensurate to the number of access points that you're trying to add. So what you do is you purchase that. The part number is LIC, I think it's 5508 250 and 5508 100 and whatever. This information might be out of date. You know, this stuff changes over time. So always, of course, check Cisco.com if you're going to look at the latest information about licensing. Cisco definitely changes their licensing models all the time. But anyway, you're going to get a .lic file, and then you can register that license to the serial number of the device. So you do have to have the serial number address for AP licenses, not for the APs themselves, but for the controller, and so on. So you can actually transfer licenses from one controller to another if you do end up changing out your controller, but you have to revoke those licenses from the current controller and then download those licenses, download the revoked licenses, and then you can upload them to the new controller. Okay? So much easier to deal with, and not as convoluted as the subscription model. In the iOS XE software, licenses are right to use, and they're actually, it's kind of like an honor system. It's just a command that you execute in the switch to activate the license. Now, image-based licenses get activated by Cisco before the switch is actually shipped to the customer. It's not going to require the customer to configure it or enable it. You are required, say in a converged environment on a 3850 or a 3650, to have at least IP base or IP services to provide the controller functionality, the converged access functionality. The LAN base feature is going to support all your layer 2 access, static IP routing, wireless for centralized environments, and so on. IP base feature is going to add things like advanced QoS features, ACLs, RIP routing, and so on. IP services gives you all the enterprise class features, hardware-based IP unicast, multicast routing, and so on. If you do want to upgrade the license to the switch, you have to go and purchase that license. You get a product activation key from Cisco, use the CLI to install that license, and so on. Okay. You can see the CLI license commands here. License right to use activate, IP services slot 1, accept the end user licensing agreement, and then you can specify the AP count that you're allowed to activate. There's actually technically nothing required to install to activate a license in these converged access controllers. It is a kind of an honor system. As long as you have the base software, the base licensing software, or the licenses for the software itself for the switch, you can then activate however many AP counts you want. Keep in mind as well with converged access, the APs that are being managed by the controller on that switch have to be physically attached to that switch. So you're not going to see a 3850 that's going to be licensed for 200 APs because there's no way to physically connect 200 APs to that switch. That's why you see the count here is 1 to 50. So this is probably a 48 port switch with a couple of other additional ports, but primarily 48 ports. So we can activate up to 50 APs in this particular switch. It's one of the downsides to the converged access architecture. If you have 10 different 3850 stacks, you're going to have 10 different controllers, because one stack cannot manage APs that are attached to another stack. It's not very, well, in my opinion, not a very good design, which is why centralized access is becoming more of the norm. All right. Cloud devices will update firmware images that are based on network-wide settings. All right. Basically, it's the devices themselves will kind of call home. They get notifications, or notifications will be sent out to you as an administrator to say, hey, there's an update. And then the AP screen as well, the status screen that you'll see when you log into the management interface, will show if updates are available. It's kind of like Windows Update. The updates kind of get identified and, hey, would you like to install this update? But you can also automatically specify whether or not firmware updates are going to be applied on a scheduled time frame. That's your automatic firmware update option. All right, so you can set the upgrade window for updates. The AP continues to operate while it's downloading the firmware, but once the firmware is applied, the AP is going to have to reboot. So you can specify the window where you want that upgrade to take place, so you're not affecting users, hopefully. Okay. Once you're notified of an update, that update can be scheduled, it can be rescheduled, or you have an option to click a button that says go ahead and perform the upgrade now. You can see here. It's grayed out right now because there aren't any available updates, right? But if there was an update, you can schedule it. Say, let's go ahead and continue to upgrade as scheduled. So Sunday at 2 a.m., you can reschedule the upgrade, or you can say, go ahead and perform the upgrade now. Devices can also use beta firmware, firmware that hasn't been baked and hasn't been tested. And that's just a simple yes or no option that you choose there. Okay. Autonomous APs simply get upgraded from their GUI or from the command line based on the IP address of the access point itself. All right. The autonomous APs, and by the way, this applies, and this is a very important note as well, guys. If you guys are going to go out and purchase your own access points for your lab or whatever on eBay or whatever it might be, they may ship as autonomous, or they may ship as lightweight, but you can change all that information. Okay, you can convert a lightweight AP to an autonomous AP. You can convert an autonomous AP to a lightweight AP. But anyway, if you want to upgrade, you can go through the GUI. This is the GUI what the GUI would look like for an autonomous AP. You can also do it through the CLI. You do have to have TFTP configured to be able to do that, but you can download the image, which is a .tar file. That's the firmware image anyway. And you can specify that using the archive download-SW. All right. Now, if you want to move from CapWAP to autonomous, you can do that from the CLI and the AP. And there's some different commands. I can't remember the exact syntax for the commands themselves, but you can find those on Cisco.com. I know it's an archive download-SW command. And there's some switches you can use, like overwrite, which overwrites the software image in the flash with the downloaded image, so you may not have enough space to cover everything. There's a force reload option. There's a reload option. There's a bunch of other switches available as well. Okay. You can also convert from autonomous to CapWAP. The conversion from CapWAP to autonomous and autonomous to CapWAP is basically changing the firmware. That's essentially what you're doing when you're trying to convert an AP from lightweight to autonomous and from autonomous to lightweight. You're just simply changing the firmware. Okay? There are many, many documented approaches of that online. It's a little bit beyond the scope of this class to talk about how that process takes place, but essentially it's just a matter of updating the firmware. Now that does assume that you have access to the AP, right? Because you have to be able to apply the firmware to the access point itself. In a centralized controller environment, software is obviously pre-installed. I mean, you're not going to get a controller sent to you with no software. But before deploying that controller, you want to make sure that you have the latest stable release of software and that all APs that connect to the controller will be synchronized to that version, right? The controller is actually what pushes out the software to the APs in the event of an upgrade, which is a nice thing of running a centralized environment. If you update the ROS from 8.1 to 8.2 or whatever it is, the controller will then push out that firmware to the APs, and then the APs will reboot in that process. The controller has a primary image and it has a backup image. So when you actually install the software initially, the new software doesn't take effect until you reboot the controller. All right? And then, by the way, you can, if there are issues that arise from that upgrade, you can switch back to the previous image because it maintains a copy of that image in the flash. All right? So you can do these upgrades from the GUI, or you can do it from the command line interface using three different options. You have SFTP, TFTP, and FTP. And you can see that in the transfer mode. Let me show you. All right. If I go to tech support, let's see. Stop. Actually, let me go to commands here. You upload a file, and you can see all the kinds of different files that you can upload, which includes the configuration file, debug, signature file, and so on. You can also schedule reboot, etc. But there should be in here. There should be. I have an older version of software here, but I thought there was a option to upload the software file here. Packet capture, panic crash, radius. Let's see. Let's go under management real quick. Activation. Why am I not seeing it here? Oh, code right here. Okay, so it's under the main. It's under the main window here. I was clicking on upload file, thinking that it would show me the code. But if you just click commands, you'll see it there. So you can see here that you have the three options: TFTP, FTP, and SFTP, and then you can specify the server information, the path. SFTP, of course, if I select that, it'll also have a username and password that I have to put into place. Okay, so that is the process. It's a very simple process. Once you upload the image, it'll ask if you want to apply the image and then reboot the controller, and then the controller will activate that particular image. All right. The controller field update software. It's an AES package that does all the hardware, firmware upgrades. This is actually independent of the controller's software level. It is recommended, although I would say you need to check with on the download section of Cisco.com, but it is recommended that if you upgrade the software for the controller, that you also upgrade the field update software. Field update software is how we push out all of the different firmware information. All right, that can also be installed via the GUI or the command line as well. Let me see if it shows up here. Field update software. Yeah, that's probably under the other option. Upload file. Let's see if it's under here. Field update software. Yeah, it's in here somewhere. I'm not sure where it's at, but you know, we don't do this too often, so you have to kind of poke around and see. They've changed these menus a little bit over time, so things kind of move around a little bit. All right. Now, there are a couple of different options when you're actually upgrading the software. When you go to Cisco.com and you go to the download the software section, by the way, you get access to that software by having a service contract. I don't know if you guys know how this works, but you may want to investigate this with your respective companies. When you purchase a Cisco product, that product comes with the option to purchase what we call a SmartNet contract. Now, Cisco's changing this. There's Cisco One, and there's a whole bunch of other types of contracts that you can purchase now, but we'll just call it SmartNet just for simplicity's sake. SmartNet is basically a maintenance contract. Now that can include coverage for the hardware, but it can also include coverage for the software. An appliance like this, that's usually going to be joined together. That once the company purchases that SmartNet contract that's tied to the serial number of the device, a contract number gets generated. Okay. Now usually it's the entity that does the purchase. And when the purchase takes place, you identify the end user, so the IT director's name or the IT manager's name and so on. And that contract that then gets associated with that person's profile. Cisco, it's called the CCO account, Cisco Connection Online account. When you go to Cisco.com and you register, that's what you're going to get. In order for you to be able to get download access, like you, Mike, and Tiju, if you want to get download access to software, you have to have those service contracts tied to your CCO profile. And contracts can be tied to anybody's profile. It can be tied to multiple profiles as well. So what you would do, and if you're doing the request through Cisco.com, when you go to your account and you log in, you can actually request additional access, and they'll actually ask you to put in a contract number. As long as the email account on your CCO account is tied to the company name, right? The domain name is tied to the company name, then that service contract can be added automatically. That way you guys have access to download software, even for your own home controller or whatever, to download software or for, as needed if you want to do any kind of update. So just a little piece of information. It's not really relevant to this chapter, but it is relevant, but it's not part of the lesson. Anyway, I got off on this tangent because there's two options when you're downloading software. There's what we call ED, and there's what we call MD. All right, ED is basically just software releases that provide new features, new hardware support, bug fixes, and so on. MD, Mike, David, are software releases that provide bug fixes and software maintenance. All right, so when you go to Cisco.com, you go to the download section, you will see those designations in the download section. ED we always kind of consider as an early adopter type of upgrade, right? Because it's adding new features, it's adding new platform support. So be careful with that, because we've seen scenarios where additional bugs get introduced by these ED deployments. Okay. AP pre-download is an option. So remember, the APs themselves are managed by the controller. The software on the APs are managed by the controller. So normally what happens is after you apply a controller upgrade, the AP reconnects the download, reconnects to the controller, and then it goes and downloads that latest firmware. Now this could interrupt service, so make sure that you're aware of that, obviously. If you want to avoid the APs kind of automatically updating themselves, you can do what we call a pre-download, where you pre-download the software to the AP. The AP would eventually still have to swap the images from the old to the new, reboot and rejoin. Okay. You also have a setup option. The controller gets updated but doesn't get rebooted, so you can kind of prepare everything, and then during a maintenance window you reboot the controller and it will go out and update the APs. All right. So during boot time, the access points send a join request. The controller responds with a join response with the new image version that the controller is running. So what happens is the access point then compares its running image with the running image on the controller. If the versions match, the access point joins the controller. If the versions don't match, the access point compares the version of the backup image. And if those match, the access point swaps the primary and the backup image and reloads and joins the controller. If the primary image of the access point is the same as the controller image, the access point reloads and joins the controller as well. Okay? If none of these conditions exist, the access point sends an image data request to the controller, downloads that latest image, reloads, joins the controller. Okay? So you don't have to go and prime all of the APs with their new image. The APs will actually go and download the image from the controller itself. All right, but this is optionally an option that's available under wireless. You can see AP image download and manage the AP images from that perspective. When you're upgrading the image of a FlexConnect AP, remember FlexConnect APs operate slightly differently than main mode APs, right? You can use the pre-image download feature as well. This might be something that you decide to do because you don't want the AP pulling down images over the WAN if the WAN doesn't have a whole lot of bandwidth. All right. So using that pre-image download can cause a lot of bandwidth to be used on the LAN because we're kind of priming the APs by downloading those images. A more efficient way is to use what we call the FlexConnect Smart AP image upgrade feature. I've used that quite a few times actually. You do have to configure a few components, right? You have to use these things called FlexConnect groups. So when you enable this feature, one access point of each model, of each version of the access points in that branch office downloads the upgrade image over the WAN link. That access point becomes the master for the remaining access points of that same model. And then the remaining access points then download the upgrade image from the master access point using that pre-image download feature. But it's done over the local branch network. It doesn't require the use of the WAN latency. Okay. To set this up, you go into the FlexConnect group and you enable there's a checkbox to enable the FlexConnect AP upgrade option. You can see that there, FlexConnect AP upgrade. You set the slave maximum retry count if you want to change it. That means that if the slave AP cannot reach the master AP after this specific period, it's going to go ahead and then just try and get the image from the wireless LAN controller over the WAN. All right. Set the image upgrade to backup if you want this to be a backup image for the AP, or you can even set an image to a master AP, or you can establish which AP is the master AP. All right, so go to configuration, wireless, it's under radios, surprisingly enough, global configuration, and you can see all of that configuration. Let me show you real quick. Wireless, radios, global configuration, and you can see the information down here. This is a image pre-download. You don't see the FlexConnect options here because this is not a FlexConnect AP, right? So we don't see all the FlexConnect upgrade options here. But had I converted this, you would see the similar screen to what we saw previously. Okay. All right, now if you click one of these, it's going to give you an option. Or do you want to pre-deploy a primary image for all Ps associated? If I say okay, nothing's going to change because I haven't upgraded the software. But now what would happen is this AP would be going out and pre-downloading that primary image. All right. Obviously, when we're doing converged access, you're working a little bit differently in this particular case because the wireless LAN controller software is part of the iOS image of the device itself. So the ability to add additional wireless controller features would actually mean the need to upgrade the actual iOS on the device. The process is, well, probably a little bit more involved than what we need to talk about here. We can talk about different boot modes and changing the software bundle packages on the device themselves. These are just the .bin images. But if you guys have ever gone through any kind of software upgrades in the past, it's just for any device, right? A router or a switch, it's the same process. It's just embedded as part of the iOS. All right. Now, interestingly enough, and this may or may not be something that you guys are used to seeing, iOS XE software has a completely different architecture than Cisco iOS. We run these daemons, right? iOS D, and D stands for a daemon, in the image, right? The XE image. And then we also have hosted applications that we can run. Things like WCM and Wireshark and so on. And those tools provide us the ability to do monitoring and management of interfaces and CAPWAP tunnels and so on. But those are installed as different modules. So it's a kind of a multi-core CPU type, more of a computer type based environment. We still have the same look and feel, right? Still command line, enable, config T, go into interface, etc. But then we can also host these applications on the device itself, which includes some wireless specific applications. The 3850, the 3650, and the 5760, those all run iOS XE firmware images, but they can have different boot modes. Say, for example, the 3850 and 3650, those can be booted in install mode, or they can be booted in bundle mode. The 5760 can only be booted in install mode, but all of the devices out of the box will be in install mode. We're going to go through a discussion of what the difference is between a boot mode and an install, or bundle mode and an install mode in a minute. But for now, just keep in mind there's two modes of operation. You can change the mode, the bundle, and the packages that are installed in the devices based on these different operations. Let's talk about what the packages are, right? Because there are different packages that are installed. The packages themselves are installed into the flash using .pkg extension. It includes the base package, which is basically just the kernel itself, driver package, which is the platform drivers for all the hardware, the infra package, which is your infrastructure software, the iOS package, which is your Cisco iOS software, the platform package, that's any software not specific to the iOS software platform, things like Stack Manager, Platform Manager, and then the wireless controller software package as well. That's what WCM is. That's the wireless controller management package. So everything is kind of installed independently. All right. Now, I mentioned these two different modes of operation, install mode versus bundled mode. iOS XE bundle images can either be copied to the flash or installed in flash so that we can add additional features to the device itself. Boot modes, well, let's talk about bundle mode first. All right. And when I describe what this is, I think it'll make more sense as to why it's even called bundle mode, right? The image is booted from flash, the image itself, and booting the 3850 switch in bundle mode is like booting any kind of Cisco iOS device. And that means that you're basically going to boot all of the modules together. You're gonna boot the device so that all the modules are active and so on. Install mode is when you're adding additional features and you want to activate an additional feature. You would install the file itself. It's a .bin file, and then you would activate that file as part of the process. I don't know if I'm even making sense here. The book doesn't really get into enough detail to really make it completely clear, but I think you understand what we're talking about here. The iOS XE software operates these different modules. Those modules can be activated or deactivated depending on what you're trying to do with that particular platform. Okay? Now, generally, and we talked about this, the devices ship in install mode. That's what Cisco usually recommend in the process because it allows for more features and it requires fewer resources. All right. Let's see. Whether or not you guys are running converged access, by the way, yeah, I know that we talked about this previously when we were talking about the lessons and whatnot. You guys are doing centralized wireless, but iOS XE is not implemented just to support converged wireless. iOS XE software is the default software packages that are installed on these different platforms, 3850s and 3650s and so on. Okay. Now, if I'm dealing with the converged access, where I'm using these 3850s, we have the capability of stacking switches. This is something you may have seen in the past, where I can take multiple switches. I can create this single virtual switch by simply stacking those switches together. Okay, there's a cable that I attach to the back of the switch. That cable allows me to interconnect those devices and have them run as a single virtual device. A switch stack has a master switch and then it has a standby switch. So if the master switch becomes available, the standby switch assumes the role of the master switch to keep that stack operational. The master switch is the one that controls all the operations of the switch stack itself. It's the single point of stack-wide management. We may have up to 9 switches in the stack, but we have one GUI, one command line, and one management. So there are a bunch of global features that get applied to all the stack members, and then you have interface-specific features that are applied to only a member of the stack because those configurations apply to that particular switch. The active switch contains the running config, the saved config, and all the configuration files for the system level settings for the particular stack. So each stack member has a copy of those files, but that's only for backup purposes. All right. Now, I'm mentioning this because that applies to the wireless component as well. All right. Now, if you're installing software in the stack, you're going through the process of upgrading the software for your wireless environment, or you're just simply upgrading the software for the stack, you need to make sure that all the switches are in install mode, number one. Upgrades are done with packages, and we deploy those packages on one switch. We identify that as the source for installing the packages on all the other switches in the stack. You can see the command there for updating the different stack members. All right, and you only need to reload the newly added switches if there's an upgrade applied. You don't have to reload the whole stack if you're applying an upgrade. To allow any kind of switch to join the stack, it has to be upgraded to a compatible image as part of becoming Well, as part of becoming part of the stack, right? And that can be done with the auto upgrade feature. You just simply do software auto upgrade enable. So if I could buy a new switch, I plug it into the stack. If the software versions don't match, the process, the stack goes through the process of upgrading that iOS on that switch so that it can join the stack effectively. All right, now why am I mentioning this? Because this doesn't really have anything to do with wireless. It just has to do with the concept of stack-wise technology and how Cisco has introduced this concept of being able to stack switches together into a virtual switch. Well, what about the AP licenses, right? If I've got 9 switches in a stack, does that mean now that I can have a license count that exceeds 50, for example, because I can have maybe 100 APs connected to that stack? Is it a single controller? Do each of the switches manage everything independently? I'll answer all those questions here. Okay. Actually, you can kind of see from the bullet points that a lot of those questions are already answered. The answer is no. You cannot add 100 APs. You cannot add 200 APs. The maximum number of APs per stack is 50. So each switch in the stack has to have an AP count license that matches the maximum number of APs connected to it. Okay. The total AP count license of the stack is equal to the sum of all the individual member AP count licenses, which is up to 50. So the total count is the sum of all members. When new members get added to the stack, the AP count license is automatically added. All right. It's interesting. It seems like it's kind of contradictory, right? You're saying, okay, there's a maximum of 50 APs per stack, but the AP count license is managed on the stack master, but the total count is the sum of all the members. What they're saying there is that one switch can have a count of 5, one switch can have a count of 8, another switch can have a count of 2, but the maximum you can have per stack is 50. Okay? The master switch will manage that. Even though the stack operates virtually as a single switch, the APs that are managed by the converged controller have to be plugged into the switch, and the controller features are configured on that stack, if that makes sense. Since you guys aren't doing the converged access, it's not something you necessarily have to be concerned with. All right. What about backup and restore? Cloud-based configurations, that's automatically backed up in the cloud. Whenever you do a save changes, after you've made some changes, the configuration gets backed up to the cloud. You can't undo those changes and you can't restore them. All right. You can clone, right? You can build a new network and clone from an existing network, and you can also synchronize the information. In an autonomous AP, there is in the GUI an option, and you can do it through the command line as well, to save the software. Basically go into the software menu, go into system configuration, click the config.txt file, and it'll just simply save it to the local PC. And then you can restore the file by browsing to the local PC and then clicking the load button. You can do this to the command line as well. It's just a copy command, like copy system TFTP or copy NVRAM TFTP to do the running config or the startup config. System is the running config and NVRAM is the startup config. And you would have to specify all your TFTP properties. In the AirOS, I kind of already showed you guys this. You go to the backup option. If you want to do commands and upload file, you can choose the configuration file if you want to restore a configuration. By the way, it's a little bit counterintuitive. Upload file means that you're actually going to be taking files from the device, and download means you're going to be restoring files to the device. It's kind of counterintuitive. You can use FTP, TFTP, SFTP, and so on. As far as backing up from the command line, you probably won't do that, but use something called the transfer command. and you can specify all the properties of that. You can see here that we're actually uploading the data type config. We're going to use TFTP. We're going to the TFTP server IP is 192.168.11.11, the path, and then start, and then it'll go through the process. Personally, I prefer to use the GUI in this case because it's much easier to manage. All right. In iOS XE switches and wireless link controllers for that matter, you have the configuration that's backed up and restored from the CLI. And that's just using a copy run TFTP command. Or you can use FTP as well. If you do all, copy run TFTP all, it will get the entire configuration, all the package information, and so on. You can use a configure replace. You can use the GUI of the device to upload files and download files. And it's not specific to the controller, it's just specific to the device. If that makes sense. You're getting the entire device's configuration. All right. So just a basic chapter lesson talking about the subscription models, the licensing models, the options that we have for backing up our devices, and how iOS XE is utilized. You know, it's a lot different, right? It's probably the more complicated scenario where you have to configure the device to host applications. You can boot the device in install mode or bundle mode, etc. We talked about a lot of that stuff. All right, so that's the end of that lesson. And what we're going to do is we're going to get into the next lesson, which is the last part of this particular module, which is all of our different troubleshooting tools. Could be third-party troubleshooting tools or some Cisco tools. We'll take a look at that as well. All right.